Toyota announcing the recall of about 100,000 tons of pickups and about 3,500 Lexus LX 600 luxury SUVs. The engines could stall, causing the vehicles to lose power while driving. Now,
278 horsepower, 317-foot torque on the combustion engine, but our hybrid version is 326 horsepower, 465 foot-pounds of torque, which is industry-leading.
You know, when we set out to create something groundbreaking, it's always about answering one big question: why? Why build a car that's insanely fast, futuristic, and electric? Well, the answer was simple: to prove that electric vehicles, EVs, are the ultimate future of transportation. Tesla's rise to dominance felt unstoppable. The world was convinced that electric vehicles were the only way forward. Elon Musk's vision of an all-electric future seemed like a done deal. But here's where things get interesting. Tesla had a strong ally in Toyota, one of the biggest names in the automotive industry. Toyota wasn't just a partner, they were a significant shareholder in Tesla. It felt like the perfect alliance. Yet in late 2024, something unexpected happened. After a secret meeting at Toyota's headquarters in Japan, Elon Musk emerged visibly shaken. What he saw that day didn't just challenge Tesla, it challenged the entire narrative of the EV revolution. So, what was it? What could possibly make the king of electric cars question the future he had built? Let's dive into the story of how Toyota, the quiet giant, was silently working on something that could turn the automotive world upside down.
CEO Elon Musk unveiling what he says is the company's first fully self-driving robo-taxi. The two-door cab with no steering wheel and no pedals is powered by AI and will cost around $30,000.
The quiet giant's game-changing move. While Tesla was busy dominating headlines and pushing the boundaries of electric vehicles, Toyota was working behind the scenes on something revolutionary. This wasn't just another hybrid system or a small upgrade. No, this was something far bigger, a technology so groundbreaking that Elon Musk himself called it a potential industry destroyer. But before we get into what this mystery innovation is, let's rewind a bit. To understand how Toyota got here, we need to go back nearly a century to the roots of this automotive giant. The story begins in a small Japanese textile company, far removed from the world of cars. Sakichi Toyoda, a brilliant inventor, revolutionized the textile industry with his creation of the automatic loom. This wasn't just any machine. It introduced the concept of jidoka, or automation with a human touch. The loom could automatically stop when it detected a problem, ensuring quality and efficiency. This principle became the foundation of Toyota's entire philosophy. Sakichi's son, Kiichiro Toyoda, took this spirit of innovation and applied it to a completely new industry: automobiles. Observing the inefficiencies of American mass production, Kiichiro envisioned a better way. He developed the just-in-time, JIT production method, which focused on producing only what was needed, when it was needed, and in the exact amount required. This approach minimized waste and maximized efficiency, laying the groundwork for what would become the legendary Toyota Production System, TPS, from textiles to automotive dominance. What started as a textile company's quest for efficiency transformed into one of the most influential manufacturing systems in history. Toyota's commitment to innovation and quality didn't just shape their cars, it shaped the entire automotive industry. But here's the twist. While the world was fixated on electric vehicles,
11 owners reported engine fires. 4 of those fires started with the engine off, wasn't even running. Officials believe there may be an electrical issue with the battery.
Toyota was quietly refining their decades-old principles to create something that could challenge the very foundation of the EV revolution. At the heart of Toyota's manufacturing excellence lies the Toyota Production System, TPS, built on 2 foundational pillars: just-in-time, JIT, and jidoka. JIT is all about synchronizing production processes to create a seamless flow, minimizing waste, and ensuring that resources are used efficiently. On the other hand, jidoka focuses on quality control, by empowering both workers and machines to detect and address issues immediately. This dual approach doesn't just boost productivity, it embeds quality into every step of the manufacturing process. But Toyota didn't stop there. Their philosophy of Kaizen, or continuous improvement, sets them apart from competitors. Kaizen encourages every employee, from assembly line workers to top executives, to actively seek out and implement improvements in their daily tasks. By fostering a culture where every suggestion is valued, Toyota created an environment of perpetual innovation. Toyota's ability to anticipate and adapt to market trends has been a key factor in its success. Take the 1973 oil crisis, for example. As fuel prices skyrocketed and consumers demanded more fuel-efficient vehicles, Toyota was ready. Models like the Corolla offered exceptional fuel economy, while many American manufacturers struggled to keep up with their larger, less efficient vehicles. This foresight and agility solidified Toyota's reputation as a forward-thinking automaker. Fast forward to the early 2000s, and Toyota once again proved its innovative prowess with the introduction of the Prius, the world's first mass-produced hybrid vehicle. By combining a gasoline engine with an electric motor, the Prius delivered impressive fuel efficiency and reduced emissions, appealing to environmentally conscious consumers. This move not only set a new standard in automotive technology, but also cemented Toyota's role as a pioneer in sustainable mobility solutions.
We're talking about more than 1.8 million RAV4s involved in this recall. Now, Toyota says the recall is for certain 2013 to 2018 models, and it has to do with replacement 12-volt batteries.
What started as a small textile company in Japan transformed into a global automotive powerhouse thanks to the principles established by Sakichi and Kiichiro Toyota. Their commitment to efficiency, quality, and innovation continues to guide Toyota, ensuring it remains at the forefront of the automotive industry. But here's the twist. While the world has been fixated on electric vehicles, Toyota has been quietly refining its decades-old principles to create something that could challenge the very foundation of the EV revolution. The internal combustion engine, ICE, has been a cornerstone of technological advancement for over a century, powering the vehicles that have shaped modern society. Its evolution is marked by continuous improvements in efficiency, power, and reliability. The journey of the ICE began in the late 18th and early 19th centuries. In 1791, John Barber developed a gas turbine, and by 1794, Thomas Mead had patented a gas engine. That same year, Robert Street built an engine that was the first to use liquid fuel. These early endeavors laid the groundwork for future developments. A significant milestone came in 1876, when Nicholas Otto, working with Gottlieb Daimler and Wilhelm Maybach, developed the compressed charge 4-stroke cycle engine. This design, known as the Otto cycle, became the foundation for most modern internal combustion engines. The 4-stroke process, intake, compression, power, and exhaust, allowed for more efficient fuel combustion and power generation. Toyota's mastery of the ICE. Toyota's journey with the internal combustion engine is a testament to its commitment to innovation and quality. The company's engines are renowned for their durability and performance. A prime example is the 2JZ engine, introduced in the early 1990s. This 3.0-liter inline-6 engine, found in models like the Toyota Supra, became legendary among automotive enthusiasts.
Production of the iForce 2.4-liter turbo engines marks big change for Toyota Alabama. Previously, the Huntsville plant only had the capability to produce combustion engines.
Its robust construction allowed it to handle significant power increases, making it a favorite for tuners and racers. Toyota has also been at the forefront of technological advancements in engine design. In 1995, they introduced variable valve timing with intelligence, VVTi, which optimizes the timing of intake and exhaust valves to enhance power output and fuel efficiency. Building on this, Toyota developed dual VVTi, adjusting timing on both intake and exhaust camshafts for even greater performance. In 2007, Toyota introduced the Valvematic system, offering continuous adjustment to valve lift and timing. This innovation improved fuel efficiency by controlling the fuel-air intake using valve control rather than a conventional throttle plate. The result? A more responsive engine with reduced emissions. As environmental concerns grew, Toyota responded by developing lean burn engines, which operate with a higher air-to-fuel ratio than conventional engines. In 1984, Toyota became the first automaker to mass-produce lean burn engines, offering improved fuel efficiency and reduced emissions. This commitment to sustainability reached new heights in 1997 with the introduction of the Prius. The hybrid Synergy drive system combined a gasoline engine with an electric motor, allowing the vehicle to operate on either power source or a combination of both. This innovation set a new standard for environmentally conscious driving. Toyota's dedication to refining the internal combustion engine hasn't waned. The company has developed new combustion engines that are more compact, efficient, and capable of running on various fuels, including gasoline, synthetic fuels, biodiesel, and hydrogen. These engines are designed to meet strict environmental standards and can be used in a variety of vehicle types, including hybrids and biofuel cars. In 2008, as Toyota was perfecting its hybrid technology, a new player entered the automotive arena, Tesla Motors, led by the visionary Elon Musk. Musk's mission was clear: electric vehicles.
Elon Musk has had his Tesla Pay blocked by a judge. According to a decision in a Delaware court, the Tesla chief executive's record-breaking $56 billion
EVs were the future. Tesla's journey, marked by bold innovation and relentless ambition, would soon challenge traditional automakers and reshape the entire industry. But let's rewind a bit. Tesla Motors was actually founded in 2003 by engineers Martin Eberhard and Mark Tarpenning, with the goal of creating high-performance electric sports cars. In 2004, Elon Musk stepped in, leading Tesla's initial funding round with a $6.5 million investment and taking on the role of chairman. Musk didn't just invest, he became deeply involved in product design and strategy, steering the company toward ambitious goals. In 2008, Tesla introduced its first vehicle, the Roadster. This wasn't just any sports car. It was an electric sports car that could accelerate from 0 to 60 miles per hour in under 4 seconds and offered a range of over 200 miles on a single charge. The Roadster shattered every stereotype about electric cars, proving that EVs could be both high-performing and desirable. The Roadster's success set the stage for Tesla's next big move. In 2012, the company launched the Model S sedan, which received widespread acclaim for its performance, safety features, and sleek design. The Model S became the first electric car to top monthly sales rankings in any country, signaling a major shift in consumer perceptions and market dynamics. Tesla didn't stop there. In 2015, the company introduced the Model X SUV, followed by the more affordable Model 3 sedan in 2017. The Model 3, in particular, was a game-changer. It brought electric vehicles to a wider audience and quickly became the best-selling electric car globally. But Tesla's ambitions went beyond just making cars. In 2014, the company announced its autopilot system, a suite of advanced driver assistance features. Musk's vision extended far beyond partial automation. He frequently spoke about achieving full self-driving capabilities.
Tesla put out an updated version called Smart Summon, which allows the car to actually steer itself and find the driver within 200 feet using the phone's GPS. On its website, Tesla points out the apps are in beta feature, which means still in development.
However, despite ambitious timelines, fully autonomous driving remained a complex challenge, with Tesla facing both technical hurdles and regulatory scrutiny. Tesla's rapid rise wasn't without obstacles. The company faced production challenges, legal disputes, and financial pressures. Musk's leadership style and public statements occasionally attracted criticism and regulatory attention. Yet, Tesla's influence extended far beyond its vehicles. The company's focus on renewable energy solutions, such as solar panels and energy storage products, aligned with global sustainability trends. Tesla's success also pushed traditional automakers to accelerate their own electric vehicle programs, intensifying competition in the EV market. As the story unfolds, Elon Musk's influence remains a central theme in the evolving narrative of electric vehicles. But while Tesla was making waves, another challenge was brewing, one that would test the entire automotive industry. As the world accelerates toward an electric future, the enthusiasm for EVs is tempered by significant challenges associated with battery production. While EVs promise reduced tailpipe emissions, the environmental and logistical complexities of battery manufacturing present a multifaceted dilemma. The production of lithium-ion batteries, the cornerstone of most EVs, involves the extraction of critical minerals like lithium, cobalt, and nickel. Mining these materials is resource-intensive and often environmentally damaging. For instance, lithium extraction in South America's Lithium Triangle, Chile, Bolivia, and Argentina, has led to significant water depletion in arid regions, adversely affecting local ecosystems and communities. Similarly, cobalt mining in the Democratic Republic of Congo has been linked to soil and water contamination, as well as human rights concerns. Beyond mining, the battery manufacturing process is energy-intensive, contributing to substantial greenhouse gas emissions.
Many Tesla drivers are disgusted and downright embarrassed to be driving the vehicle, now widely associated with Musk's attacks on Canada.
Studies show that producing a single EV battery can emit up to 4 tons of CO2, requiring years of vehicle operation to offset this initial carbon footprint. Additionally, the global supply chain for battery materials involves extensive transportation, further increasing emissions. The finite availability of essential minerals poses another significant challenge. As EV adoption rises, the demand for lithium, cobalt, and nickel is expected to outpace supply, potentially leading to resource shortages and increased prices. This scarcity is worsened by geopolitical factors, as a substantial portion of these minerals is concentrated in politically unstable regions. For example, over 60% of the world's cobalt supply comes from the Democratic Republic of Congo, a nation plagued by political instability and ethical mining concerns. Addressing the environmental impact of EV batteries extends beyond production to include end-of-life management. Currently, only about 5% of lithium-ion batteries are recycled, primarily due to technological and economic barriers. Improper disposal can lead to soil and water contamination, while efficient recycling could mitigate environmental harm and alleviate resource scarcity by recovering valuable materials. Companies like Nissan and Volkswagen are investing in battery recycling initiatives, but widespread implementation remains limited. Recognizing these challenges, Toyota has adopted a more measured approach to electrification. The company has emphasized hybrid technology and is investing in alternative solutions like hydrogen fuel cells. Toyota's strategy reflects a belief that a diversified approach, including hybrids and hydrogen-powered vehicles, may be more practical and environmentally responsible in the short to medium term. This approach aims to balance consumer needs, environmental impact, and resource constraints. But Toyota's engineers haven't stopped there. They've been exploring innovative solutions that go beyond traditional paradigms, leading to a groundbreaking development that could revolutionize the future of transportation.
Lauren Steve, Toyota Alabama President Jason Puckett says this announcement is a huge step toward Toyota North America's goal of carbon neutrality by the year 2035.
Toyota has consistently demonstrated a commitment to innovation, balancing environmental responsibility with performance. Building on its legacy of engineering excellence, the company is pioneering a new generation of internal combustion engines, ICEs, that promise to redefine industry standards and challenge the prevailing shift toward electric vehicles. In 2024, Toyota, in collaboration with Subaru and Mazda, announced the development of advanced ICEs designed to integrate seamlessly with hybrid systems and operate on carbon-neutral fuels. These engines are engineered to be more compact than their predecessors, allowing for vehicle designs with lower hoods and improved aerodynamics, thereby enhancing fuel efficiency. Toyota's latest engine innovations focus on achieving higher thermal efficiency and versatility in fuel usage. The new engines are designed to run on various fuel types, including gasoline, synthetic e-fuels, biodiesel, and hydrogen. This flexibility not only reduces reliance on fossil fuels, but also aligns with global efforts to minimize carbon emissions. A significant engineering breakthrough in these engines is the reduction of piston stroke, resulting in a more compact design. This modification posed considerable challenges, but ultimately led to engines that are 10 to 20% smaller than existing models. The compact size allows for lower vehicle front ends, optimizing airflow and contributing to better fuel efficiency. To compensate for any torque loss due to the shorter stroke, the integration of electric motors provides instant power, ensuring that performance isn't compromised. One of the most groundbreaking aspects of Toyota's new engine technology is its capability to utilize hydrogen as a fuel source. Unlike traditional fuel cell vehicles that convert hydrogen into electricity, Toyota's approach involves the direct combustion of hydrogen within the engine. This method leverages existing ICE technology while producing zero carbon emissions, with water vapor being the primary byproduct. Toyota has accelerated the development of hydrogen combustion engines through its participation in motorsports. By deploying hydrogen-powered vehicles in racing scenarios, the company has been able to test and refine this technology under extreme conditions, gaining valuable insights that inform the development of consumer-ready models.
Toyota says it can short-circuit and cause a fire. Now, Toyota is still working on this fix. Once that's done, dealers will be able to replace the clamp and the battery tray for free.
Toyota's commitment to advancing ICE technology is further evidenced by its strategic partnerships. In 2024, Toyota, Subaru, and Mazda announced a joint initiative to develop new engines optimized for hybrid systems and compatible with carbon-neutral fuels. This collaboration aims to refine engine technologies through shared expertise and friendly competition, ensuring that the resulting powertrains meet diverse consumer needs while adhering to environmental standards. Looking ahead, Toyota plans to integrate these advanced engines into its vehicle lineup by 2027. The focus will be on hybrid applications, where the new ICE units will work in concert with electric motors to deliver enhanced performance and efficiency. Toyota's development of highly efficient, versatile internal combustion engines presents a compelling alternative to the all-electric paradigm that has dominated recent automotive discourse. By offering engines capable of utilizing carbon-neutral fuels and delivering exceptional performance, Toyota challenges the notion that EVs are the sole solution for sustainable transportation. This innovation not only provides consumers with more choices, but also addresses some of the limitations associated with EVs, such as battery production impacts and charging infrastructure challenges. As the automotive industry continues to evolve, Toyota's groundbreaking technology could play a pivotal role in shaping the future of transportation, a new dawn for internal combustion technology. As Toyota prepares to introduce its groundbreaking engines to the market, the automotive industry may witness a renewed appreciation for the potential of internal combustion technology in achieving environmental objectives. But Elon Musk, the face of the electric vehicle EV revolution, says there's more to the story than meets the eye. By 2023, the automotive industry faced a confluence of challenges that began to reveal the limitations of an all-electric future. Electric vehicle sales growth showed signs of slowing in major markets. Charging infrastructure struggled to keep pace with the rising number of EVs, and concerns about electrical grid capacity became more pronounced. Additionally, the fluctuating prices of raw materials essential for battery production, such as lithium, cobalt, and nickel, and the environmental concerns associated with the disposal of aged EV batteries emerged as significant issues. Despite the initial surge in EV adoption, recent data indicated a deceleration in sales growth. Factors contributing to this slowdown included the high cost of EVs compared to traditional vehicles, limited driving range, and insufficient charging infrastructure in many regions. Consumers remained hesitant to fully embrace electric mobility, leading to lower than expected sales figures.
Toyota recalling nearly 2 million RAV4 SUVs. That recall affects the 2013 to 2018 models. Toyota says the RAV4s might carry a fire risk caused by poor-fitting replacement batteries.
For instance, in the United States, electric vehicles accounted for for 18% of sales between January and October 2024, falling short of the 22% target set by regulatory mandates. The rapid increase in EV adoption highlighted significant shortcomings in charging infrastructure. Many areas lacked adequate charging stations, leading to long wait times and inconvenience for EV owners. Moreover, existing electrical grids in several regions were ill-equipped to handle the additional load from widespread EV charging, raising concerns about grid stability and the potential for increased energy costs. The production of lithium-ion batteries, which power most EVs, relies heavily on raw materials such as lithium, cobalt, and nickel. The prices of these materials have been highly volatile, driven by supply chain disruptions and geopolitical tensions. On top of this, the environmental impact of mining these materials, coupled with challenges in recycling used batteries, has raised questions about the overall sustainability of EVs. In response to these challenges, several traditional automakers began re-evaluating their aggressive all-electric strategies. Companies like Ford acknowledged that hybrid vehicles might play a more substantial role in the near term than previously anticipated. Amid these industry-wide challenges, Toyota's cautious approach to full electrification appeared increasingly prescient. The company continued to invest heavily in hybrid technology and alternative solutions, such as hydrogen fuel cells, positioning itself to offer a balanced portfolio of vehicles that cater to varying consumer needs and regional infrastructure capabilities. This strategy not only mitigated the risks associated with an all-electric approach, but also aligned with global efforts to reduce carbon emissions through multiple pathways. As the automotive industry grapples with these complexities, Toyota is reportedly preparing to unveil an innovation that could challenge prevailing assumptions about the future of transportation. This development promises to combine the strengths of internal combustion and electric power, offering a compelling alternative in the quest for sustainable mobility.
Elon Musk reportedly held talks with investors about raising up to $3 billion to repay some of the debt he accrued from his Twitter purchase. Musk's team reportedly said that if the company is successful with the equity raise, it could be used to pay down an unsecured portion of the debt.
The game-changing visit, Elon Musk's encounter with Toyota. In late 2024, something extraordinary happened behind closed doors. Elon Musk, the face of the electric vehicle revolution, made an unexpected visit to Toyota's headquarters in Japan. While such meetings between automotive executives aren't unusual, what made this visit different was its unprecedented level of secrecy and the events that followed. According to sources familiar with the matter, Toyota's CEO, Koji Sato, personally invited the tech mogul to review their latest technological developments. This unusual move sparked speculation throughout the industry. Why would Toyota share their closely guarded secrets with their theoretical competitor? The meeting is said to have lasted over 6 hours. During this time, Elon was granted access to Toyota's most advanced research facility, where their next-generation engine technology was being developed. What happened in that facility remains largely confidential, but the impact was immediately apparent. Several engineers who worked closely with Elon reported a notable change in his demeanor upon his return. The billionaire appeared unusually contemplative. When pressed about the visit, Elon Musk simply stated, "Toyota's new engine will destroy the entire EV industry." What did Elon see? While specific technical details remain under wraps, industry experts believe Toyota has achieved something previously thought impossible, an internal combustion engine that combines unprecedented efficiency with near-zero emissions. The system reportedly integrates advanced hydrogen combustion technology with a revolutionary hybrid system that requires minimal rare earth materials. The implications are staggering. Such an engine would offer the convenience and quick refueling of traditional vehicles while matching or exceeding the environmental benefits of electric vehicles. More importantly, it would sidestep many of the challenges facing mass EV adoption: grid capacity issues, charging infrastructure limitations, and the environmental impact of battery production. When asked about the technical specifics during a recent Tesla earnings call, Elon's response was uncharacteristically reserved. "I made my decision to respect Toyota's wishes and not reveal any technical details to the public. What I can say is that they've achieved something remarkable, something that's pushed me to think differently about the future of transportation. Tesla will need to work much harder to create something even better." This statement coming from Elon Musk, speaks volumes. It suggests that Toyota's innovation is a fundamental breakthrough that could reshape the entire automotive industry. Industry analysts suggest that Toyota's new engine technology could begin appearing in production vehicles as early as 2026. The company has already filed numerous patents related to advanced combustion systems and hybrid powertrains, though the specific details remain heavily guarded. What's clear is that this development has forced a re-evaluation of the automotive industry's future. The assumption that battery electric vehicles would completely replace internal combustion engines is being challenged. Instead, we might be entering an era where multiple technologies coexist, each serving different needs and markets. So, what does the future of transportation look like after hearing all of this? Will Toyota's innovation redefine the industry, or will EVs continue to dominate? Let us know your thoughts in the comments below.